India's energy story is entering a new phase. For the last decade, the conversation was dominated by renewables, solar parks, batteries, and transmission infrastructure. But as India pushes towards becoming a $10 trillion economy, electrifies mobility, builds semiconductor fabs, AI data centers, green hydrogen plants, and advanced manufacturing facilities, a difficult question is emerging. Where will all this reliable power come from? Increasingly, the answer seems to include nuclear energy. For the first time in decades, India is opening the door to private participation in the nuclear sector, accelerating work on Bharat's small modular reactors and rethinking the role of engineering, manufacturing, and infrastructure in strategic sectors. At the center of many of these conversations sits Tata Consulting Engineers, one of the first companies helping design the physical backbone of India's industrial ambitions. Leading that effort is Amit Sharma, Managing Director and CEO of Tata Consulting Engineers, who recently argued that India could deploy modular Bharat small reactors within 2 years through private sector participation and a more pragmatic approach to modularization. Amit sir, welcome to Front Page.
Hi, good afternoon.
How are you doing today?
Good, great.
Good to know. So let me begin with something you spoke about recently. You recently argued that India doesn't need to wait a decade for Western-style SMRs and that Bharat small reactors would become deployable within 2 years using India's existing PHWR expertise and private participation, of course. That's a remarkably aggressive timeline. What makes you feel confident that this is something we can carry out?
As you rightly said, Sanjana, I think the most important thing for a country to get to a trajectory of growth is availability of continuous, affordable, and reliable power, which is energy. And I think if you look at our history in India, we've had our foray in nuclear, which is almost now close to 70 years old, right? In fact, in 1945 was the time when we first looked at nuclear, and we had our Atomic Energy Act in 62. And since then, India has done remarkable work, although in a way focused on a lot of strategic objectives. We do have 23 running reactors producing about 8.5 gigawatts, and about 6 gigawatt of projects are under construction. Which will take the capacity which the current Department of Atomic Energy and NPCIL is working on. But what is remarkable is India learned making these reactors in a step-by-step manner. From an initial experimental reactors, 100 megawatt to 200, then 540, and now we have a 700 megawatt fleet. And I think some great work has been done by Department of Atomic Energy and NPCIL for the past many years. Tata Consulting Engineers has been part of this work in close collaboration with DAE and NPCIL.
Right.
And in fact, our first chairman was Dr. Sethna, who was the chairman of AEC, and after his retirement became TC's chairman about 55 years back. So that's our legacy. And one of the thought process has been that since we worked on these reactors over the years, the 220 megawatt pressurized heavy water reactor that we have is a perfect candidate that it can be taken forward, modularized, re-engineered, and it's already certified. We have multiple 220, 540, 700, the same class of reactors working in India, as I said, 23 reactors. And so if we are able to look at this certified and proven and safe reactor, it at a price point which is suitable for India, I think we can certainly embark on the small modular reactor journey in the next 24 months.
Right. So I think I'd also like to understand that for years, nuclear energy was not a main topic of discussion, especially in India's energy transition. So why are we suddenly looking back at nuclear energy, and why is it back in conversation?
Yeah, I think it's a global phenomenon. I think if you look at multiple factors that are contributing to this, the first one is a real demand for energy change in the whole supply chain of energy. And with AI, data centers, and a need for energy across the globe, everybody's realized that nuclear, apart from all other things, also has a big role to play.
Right.
And so it doesn't mean that it's only nuclear. I think we need hydro, we need wind, we need solar, we need large nuclear reactors, small and medium nuclear reactors. And of course, there is space for coal-based energy as well in as much green format as we can do. So I think energy is the topic, and globally, it is under question. In fact, the G20, which happened about 4 years back, we wrote a paper with Niti Aayog, which talked about the emergence of nuclear and the small modular reactor across the globe. And so India is part of a global realization that nuclear is a clean energy, affordable energy, and a safe energy.
Right. So when we look at India's ecosystem as a whole, reaching its manufacturing and the peak of semiconductor, AI, electrification ambitions, especially with renewables, how do we understand the baseload nuclear power becoming unavoidable?
That's a very good question. I think while solar has been a very good story of success in India, and it had policy benefits, financial benefits, and adoption, so is wind or other forms of energy, whether it's hydro, wind, or solar. These are all green energies. But one of the challenges they suffer is that they are not 24/7. And they are what is called as a following load, grid following load. But when you require energy that is in surges, ups and downs, for example, as they say in the evening, a lot of industrial loads comes in. During summertime, you have a lot of consumption, both in terms of residential and commercial. You need a base load. And that is what thermal power or coal-fired power plants were giving us. Now, to manage the grid, make it stable, nuclear is a very good source of base load, which is 24/7. And more importantly, it can take up these surge demands, especially in the way that the data centers and a decentralized power requirements will become the need of the hour across the country, not just in India, but in every other nation in the world. And I believe a distribution network that is stable, coupled with renewable sources of energy, requires as a must a strong base load to make the grid stable. That is why nuclear will definitely play a big role in combination with renewable sources of energy.
Definitely, I think that's something something very interesting to look at, and that brings me to a question around Bharat's small modular reactors. What kind of role do you think they play in India's future energy mix, and how different are they from the SMRs being built in the US or Europe if we look at a global scale?
Okay, so this question requires a context. Very few people know that India's grid is very unique. Probably we are the only country in the world that has a large private captive power generation. And the reason for that is that we, over the years, as we built our grid, it wasn't very stable to provide a lot of power to the captive requirements of the industry. So whether we had cement plants, steel plants, aluminum plants, or manufacturing plants, most of these private sector plants have their own captive power generation.
Right.
And the sum total of this is about 85 to 90 gigawatts. Now, nowhere in the world is captive power plants of this total size of 90 gigawatts. Okay. And the reason, as I said, is India is a large country. We require a lot of energy. And so most of the private sector created own captive power. And this was basically coal, diesel, and so on and so forth. So the next question, how does nuclear play? Nuclear has two interesting scenarios. One is the large nuclear reactors, which will provide electricity to the grid, as we call as the IPP. And then you have the captive power plant, CPP, which can replace the small or medium thermal coal-fired power plants or diesel gensets, which is part of the captive requirements of the industry, right? And so when we talk about small modular reactors, typical definition is less than 300 megawatt. Now the sweet spot is between 150 to 200 megawatt for a large industry like steel, cement, chemical. But a large percentage of reactors are in the 20 to 50 megawatt range as well. And this is where the term comes as medium MMRs. Rather than small, we call it micro modular reactors. So MMRs and SMRs are reactors for captive requirements, but could also provide electricity to smaller towns, villages, or requirements, for example, in our Andaman and Nicobar Islands or Lakshadweep, where we require electricity of a certain scale between 50 to 100 megawatt. And all kinds of nuclear, large, medium, small, will be required for the demand that India will need, both in terms of our technological advancements, manufacturing, but also in terms of the per capita electricity expansion that India will see naturally with our population and growth as a developed Viksit Bharat plan that is underway currently.
Right. I think I'd also like to understand when you talk about modularization in terms of our country, you've called the approach a bit more pragmatic than the Western approach. So, what exactly does India understand about modular nuclear deployment than what maybe others might be missing?
Okay, so first, if you look at the maths on these reactors, some interesting things come to play. The first thing is, for a reactor, 45% of the total investment in the capital project, I would use the word, is wasted in interest during construction and escalations of price. So if you make a reactor for 100 rupees, 45 rupees is actually part of the interest cost. And because these reactors, through various reasons, right reasons and safety reasons, take 6 to 9 years, the escalation happens in 6 to 9 years. So 45% of the money goes there. Right? Number two is the cost of a reactor, which is the core complex technology, is less than 15%. The remaining costs are primarily civil construction, balance of plant, which is turbine, generator, electricity, distribution, etc. So based on these learnings, the second point I would argue is, if you look at the price point of India, China, and Korea, because they haven't looked at multiple reactors, they are 2 to 3 times lower than the cost in US and France. Okay? So if you make something and you make multiple things of the same design, you learn and you get economies of scale, right? And so your ecosystem of tier 1, tier 2, tier 3 suppliers are able to distribute the cost of investment across multiple orders, right? So if you take these two things, the difference between India, as we embark upon this post-Shanti Bill nuclear renaissance, is we must look at a Gen 3 plus reactor such that we pick up the proven technology of last 50 years. And second, we build in scale so that we get economy of scale. And the third is, while we must look at the generation 4 reactors, which everybody is trying to create in the world, please note that reactors and their regulatory approvals and certification takes between minimum 8 to 10 years. And while we must look at Gen 4 reactors 10 years from now, we must embrace the Gen 3 plus reactors where we have a proven 50 years experience. And in a combination of a phased approach, phase 1 being Gen 3 plus and phase 2 at Gen 4, we will be able to kickstart our ambitious post-Shanti nuclear renaissance in the next 24 months, get something going fast, and at 2035, embrace the advantages of Gen 4 reactors.
Right. I think as you also talked about scale and expansion, I'm curious to understand the semiconductor industry. In that sense, when we look at that, that is an industry which consumes enormous amounts of uninterrupted electricity and water. So do you think SMRs are likely to become like a power plant for this industry when we look at, even growing ambitions related to fabrication plants?
Yeah. So, data centers as well as semiconductors are a must for a country which has an ambition what India has really made a roadmap for.
Right.
And these two industries require very calibrated and sensitive working with input, materials, operation, and a very high robust, high quality power. Right? Both in terms of frequency, availability, harmonics, and continuity. And so the base load is very important for this. And you're absolutely right, both for semiconductors and surrounding areas, but also for data centers. I think the nuclear provided power in the SMR, MMR range, apart from the large reactors, will be a critical requirement for the country as we move forward. And I believe it's the right timing as India gets into the semiconductor mission ISM-1, ISM-2, and also look at our data center and AI strategy. Right. This is the right timing for the nuclear arena to go hand in hand.
Right. When we also, earlier you mentioned the Shanti Bill. When we look at the Shanti Bill and the proposed changes and the nuclear liability frameworks, could that fundamentally reshape the sector? And how significant is that moment for the larger nuclear industry in India?
No, it's pivotal. It's a milestone that the country has taken an historic decision on. And I think it'll open up a great innovation, manufacturing, and an ecosystem that allows private players to collaborate with established public sector entities that have considerable experience. So there's a lot of learning between private sector and the public sector in this. And I think we need to work collaboratively. It's a sector that requires careful planning, long capital cycle, a careful financial model, insurance model, proper liability understanding, trained manpower, and a lot of tier 1, tier 2, tier 3 players. So the Shanti Act, as I said, is a historic next step. And now true collaboration between private and public will enable India to go on a path of adopting nuclear for a stable energy moving forward.
Right. So largely the sector has always also been government-led. When we look at private capital and private engineering capabilities, how does that change the equation? Just from like a collaboration perspective, also what were the drawbacks in the government-led sector, and what is being added with the private coming in?
Well, couple of things. See, nuclear in India was under the government control because the purpose of that was more related to our national strategic objectives, not to produce power. That was a secondary objective, right? Now, the primary objective is electricity generation. And if you want to scale that, as I said, a collaboration between private and public is important. Private has not only funds, but also a desire to make their products greener, faster, more innovative. And the public sector has a lot of experience. So if you combine these two together, it'll help India really go fast.
Also, I'd like to understand. Previously, we talked about other sources of renewable energy, and you talked about how that compares to nuclear energy. Do you see a future where large industrial operators could potentially operate nuclear the same way they would operate captive thermal or renewable plants today?
So there are two parts of this usage, as I said. There
Right.
will be people who will generate electricity for the grid, which will
Mm-hmm.
be the large reactors, right?
Right.
And that itself would mean 1,000 megawatt to upward of 1,000 megawatt large reactors.
Mm-hmm.
This is power generation players.
Right.
The second category of players are captive players.
Hmm.
And that's where you will see reactors from, say, 20 megawatt to 200 to 300 megawatt. And yes, nuclear is safe. The Gen 3 Plus and the modularity that we are introducing world over allows people to use that in a safe manner. And I do foresee that we will see a combination of land-based, uh, floating barrage-based in the sea,
Right.
as well as micro reactors
Mm-hmm.
for electricity, but also for process requirements. See, the small modular and the MMR and SMR is not just for electricity. Most of the industry uses this for steam and process heat. And there, the efficiency of conversion is much better.
Right.
Traditionally, if you produce electricity, you have a conversion of about 35-36%. But if you use process heat and steam, your conversion efficiency would be 70 to 80%. And that's why small reactors would have multiple purposes: hydrogen generation, process heat, steam, and also electricity. So you'll have hybrid outcomes. And definitely, they can be used by the private sector with the right trained workforce and a strategy that focuses on both capital phase and operation phase.
Right. Also, when we look at India as a country, we've largely been a place which excels in engineering services. So, looking at sectors like semiconductors, nuclear, aerospace, or advanced manufacturing, in that sense, can that help India sort of move towards an engineering ownership or IP creation better as compared to when we look at a global scenario?
No, you're absolutely right. One of the story on Vikasit Bharat has to be our own blueprint of what we want to use. And I call that design and engineering sovereignty. Um, in the current AI, the use of LLMs, also I feel that India should look at its own model. So just like we are having this debate about AI sovereignty, where we have our own Indian models, whether it's language, whether it is our own innovations and our price point. Similarly, in design engineering, we must look at the requirements of India and its unique footprint, right? While we must collaborate and figure out what is the best available, we must also invent and create the requirement for our climate conditions, for our intensity, for our population, and for the diversity across the weather patterns we have in India. And hence, as we move forward to really investing efforts in aerospace, the whole Atmanirbhar Bharat in semiconductors, advanced manufacturing, as well as chemicals value chain, I think design engineering is an integral part, just like manufacturing and operation is an integral part of the success. And my last point on this topic
Definitely.
is one needs to understand what is a capex mindset and an opex mindset. And both have to coexist. Just like you need very good operational talent, we also need very good capital projects talent. Um, Now, there have been some very interesting projects that we are working on semiconductors, battery plants, base ingot and wafer, silicon production, similarly high-speed rail, and its required ecosystem of high-speed, coaches. So I think this all proves that if there is a clear strategy, intent, India will certainly meet that challenge. And the youth of India is an asset, and the tenacity and perseverance of our youth to deliver projects is proven, whether it has been with ISRO or the private sector or with NPCIL and DAE. I think we have produced some excellent benchmarks. And I feel that as these new sectors emerge, we will continue to use the talent in the country with a clear roadmap and strategy to achieve our objectives.
Right. I think this also brings me to an important conversation, which definitely is something that everybody's delving into now, which is AI. So, considering TC is also spoken excessively about digital engineering, digital twins, and AI-driven infrastructure delivery. How is AI changing the way large infrastructure projects are, designed and executed, and how does that take us away from traditional ways of, just infrastructure?
So, since we have been in this industry for almost 65 years, our talents internally in the last 2, 3 decades worked on a lot of computer-aided design and expert systems. But it was done in the technology of that time. But there was a lot of IP and knowledge. And what we realized is with faster computing methods and hardware, which is more affordable, we could leverage that knowledge. So about 4 years back, we started experimenting and collaborating with players. So AI is a calculator. Right? Just like you can use a calculator for faster calculation, imagine an exponential calculator. Only if you know your subject can AI be a friend. And so if you look at both in terms of knowledge and IP monetization, agility, modularity, and standardization, and applying physics and non-physics models to create predictable engineering outputs, I think AI is an accelerator in that respect. And all of us, in whichever industry we are in, must be very honest to the fact that AI will fundamentally rewrite the rules of both the capital, the operational, as well as knowledge-based jobs and the hard to do civil engineering and manufacturing jobs. AI will be all pervasive, right? And so we need to figure out what scenarios we need to embrace. So for us, we're looking at AI-enabled engineering, AI-enabled project management and scenario planning, and also AI-enabled value engineering. And it is a phased approach. It is going in step-by-step manner. We do see early success in areas that are low-hanging fruits. But I believe as the landscape is maturing, as the technology is maturing, we will see exponential outcomes. And our thesis is that AI is a collaboration of humans and technology to enable accelerated, predictable outcomes. And if used in the right mechanism with careful planning and strategy, it can be an exponential accelerator.
Definitely. I think thank you so much for giving those particular inputs on the involvement of AI when it comes to that, because that's definitely something very important to talk about now as industries are also evolving. I think I'd also like to understand from your perspective, what do you think are the biggest infrastructure bottlenecks for India when it comes to being an ambitious manufacturing superpower?
Yeah, I think while the ease of doing business and the regulations around various project clearances is seeing a positive shift. And there are states that are very proactive in attracting investments. I think one of the mindset change that India would have to do is to truly look at proper focus on how capital projects are done. We've done some great projects in India, but we do have problems related to planning, better appreciation of procurement processes, due focus on the early concept and design alternatives. Because the initial decisions are the most important. Changes later in the life cycle of the project are much more expensive. And so one of the mindset change we require is better planning and an honest planning of the timelines. If a project takes 25 months, it takes 25 months. Don't try and do that in 15 months, right? And while the pressure must be there to do the project in time, one needs to be honest about that planning. Second, spend a lot of time in early discussion, debates, options, alternatives. Look at the pros and cons, and then decide a strategy. Look for all localization of items that can be procured in India. Work with your suppliers to develop them along with your own strategies of the project, and collaborate with the best in the world. And this requires a very thorough capital project strategy. And why I say that, it's like we need doctors, and they must do the best with the patient. When doctors need a hospital, the hospital should be built by civil engineers, right? So that's called the capital mindset. So while we need a great doctor, we need a great civil engineer. Similarly, we need great operators of semiconductors. We need great operators of battery plants, nuclear plants, but we need great engineers, civil engineers, geotechnical engineers to do capital project. If we mix this together, we would have wrong examples. So we need a delicate balance between capital mindset and an operation mindset. And both have to respect both sides of the value chain. And so these are some of the things India is learning. We are working with our customers, with our collaborators and partners, and all of us together are learning. And I believe there is respect in the ecosystem to balance it carefully between CapEx and OpEx and make sure the investments produce the desired outcomes.
All right, thank you so much, Amit. I think this was a wonderful conversation, and it gave so much input around all sorts of things, nuances that we need to look at when we think about nuclear. So thank you so much for sitting down with us today and give your insights. This was a truly pleasurable conversation.
Thank you very much for the invite, Sanjana. It was a pleasure speaking with you. Thank you very much.
Thank you. So, ladies and gentlemen, here we had a wonderful conversation with Amit, learning around different nuances of nuclear energy, how does it compare to renewable energy, and what steps does the country need to take when we go forward from just regular sources of renewable energy to nuclear, and different industries to look into like aerospace, semiconductors, especially with the coming up of the fabrication plants. So, hope you all enjoyed the conversation. Let us know in the comments what you think, and like, share and subscribe, and don't forget, think AI, think IIM.